Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This is part 2 of my string class mini-series. I'm going to open up my web browser to my website, javacjava.com, click begin. Scroll all the way down to string class part 2. The string class is immutable. What does that mean? An immutable object is an object whose state cannot be modified after it is created. Java uses the term state to describe the values that variables or fields hold for an instance of an object. In this tutorial, I will create a mock string class that is similar to the real deal and demonstrate how to make it immutable. So, mutable characteristics. Apply the final modifier to the class to ensure it cannot be inherited, in other words, become a superclass. Instance variables or fields should be private and final. Do not create a no-argument constructor. Create a constructor or constructors that initializes the private final instance variables. This ensures they can only be initialized once. Remember that Java is a pass by value, so any reference variables received as constructor parameters must use a technique called defensive copying. Do not create any setter methods that change the state or values of the object in any way. This tutorial will build on concepts learned from my final classes tutorial, passing variables to methods and constructors tutorial, and final reference variables tutorial. So you should basically understand what the final modifier does when put in front of a class there. You should also understand what the final modifier does to reference variables, and you should also understand, pass by value, which is passing variables to methods and constructors in that tutorial there. If you don't understand those things, you might find this just a little confusing in this tutorial. So I recommend watching those if you haven't thus far. So I'm going to go ahead and come down here and copy all this, highlight and copy all this code here. I'm going to move the browser off screen here. I've got a shortcut to the command prompt set up on my desktop, but if you don't, you can right click, select new, and then shortcut. Type in CMD, next, and finish. It's just that easy. Okay, first thing I'm going to do is type in javac, which is the Java compiler command. You should see a bunch of stuff scroll by. If you get an error message, you're going to want to watch my tutorial on installing the Java Development Kit. You want to make sure you get that installed and configured properly before continuing. CLS to clear the screen, CD space /. CD is short for change directory, and / tells it to go to the root. I'm going to make a directory with the MD command. I already have that, but if you don't, it'll create it for you. Change directories to the Java folder, and now I'm going to make another directory called string2. Change directories to the string2 folder and notepad string2.java. Okay, let's go ahead and paste all this code in here, save. Now ignore all the stuff that's commented out down here. I'll get to that as I go throughout the tutorial here, but here's basically what we've got. Class string2 has the main method entry point. First statement I'm executing here basically is initializing a char array, my chars, and setting it equal to ABC, right? And this, remember, an array is an object, so the ABC lives on the heap memory. And my chars is merely a reference variable that points to that, that object on the heap, okay? So come down here to string-like here, and I'm basically declaring, not initializing, a private char, and then this this value variable, value reference variable, just declaring it, not initializing it. I'll be initializing it in the constructor. So inside of the constructor, I've got a single parameter, which is a character array called value, right? And basically, I'm setting this dot value reference equal to the value that comes in here, okay? Value parameters. So let's go through this next line up here, this next statement up here. So I'm creating a string-like type, object type, reference variable s, and I'm setting that equal to the new reference of a string type object, and then I'm invoking the string-like constructor that matches this signature, which is basically having a char array and as the parameter, right, which is this right here. So my chars holds a reference to this object. We're passing the reference the value of the reference, not the value of the object, right? Because Java is passed by val. So the argument here, my chars, is a reference variable. The parameter comes into the constructor as a reference variable, right? As a reference value, not the actual ABC. And we're setting that reference value right here. We're setting this local reference value equal to that reference value. So when all is said and done, after this statement finishes, this value right here, this reference value inside of here, points to this object on the heap. Okay, that's important to understand. Then I'm just going to display the reference value here of the string-like object. Okay, which is just basically going to say like string-like, and then plus the @ symbol, and then a hexadecimal memory location of where this object is actually located, right? So where S is kind of pointing to. All right, which doesn't do much for us, but I'm going to show you how we build this thing here. So let's compile this, run it. Java string 2. Okay, so we get string-like, and then @ and then plus whatever this little memory address is. All right, so that doesn't do us a whole lot of good at all. So if we come back over, bring over the browser, and I come up to the Java class object, right? Now, if you've been watching my tutorials, you know that every single class in Java is at some point derived from the object class. The object is the granddaddy of them all. And it contains a whole bunch of methods. Actually, not that many, like just these right here. But basically, we're interested in this toString method here, right? So if we come down here and we click on toString, this returns a string representation of the object. In general, toString returns a string that textually represents this object. The result should be a concise but informative representation that is easy for a person to read. It is recommended that all subclasses override this method. Okay? And basically what it does, it returns, you know, the class name. In this particular case, it was string-like, right? And then the @ symbol, and then this hex string of the hash code. Now we're going, okay, well, what's a hash code? You don't really have to worry about a hash code. I'm going to come up here to the Hashcode method here, and I'm just going to pull this one little port piece out here. So this is typically implemented by converting the internal address of the object into an integer, right? So that basically is what that represents right there. That's the internal address on the memory heap of where string-like is pointing to. Okay, well, that doesn't do us much good, does it? If we're trying to like create a string-like thing there. So we're going to override the toString method here. And by overriding it, we have to have a couple of things here. You can see that it returns a string, right? And it doesn't have any parameters in its parameter list here. So it's pretty simple to do that there. What we're going to do is override it here. And I'm just going to come down here and grab my override code and paste it in there. Okay, so we're returning a string, and here's our toString. I'm declaring it as public because it actually is up there, but don't worry about that. So override, right? And we're going to be returning a string value. So I'm going to say return a new string and this dot value, because this dot value, this value right here, is holding our current state, right? Or for the string-like object there. Okay, so let's go ahead and come up here and save this. Recompile it. Run it. Okay, now it's starting to act more like the string class. We've got returned back ABC, right? So we passed in a character array and we got back its value right here, ABC. Okay, let's see. So the next thing that I'm going to do is I'm going to, so far this is totally mutable, right? None of the rules that I've talked about are actually applied here, other than I don't have a no argument constructor, but I'm not going to worry about that right at the moment there. So what I'm going to do next is I'm going to put in a setter method here, right? Called change value. And that will allow us to pass a value reference to a char array into there, and then we can go ahead and change this value here, right? So this is totally everything what we're doing is mutable. And I'm going to come down here, take this particular code and put this up here. Okay, so now I'm going to change the values of the array on the heap there to DEF, right? So no longer will that object hold DEF there, the original char array. It will hold, or I'm saying it won't hold ABC anymore, it'll now hold DEF. And then I'm going to pass it my chars, which is the reference to this object, and then we'll display it. That reference then, of course, inside of this method here, will then be assigned to the value up here, right? And then we'll display it to the console. Okay, so that looks pretty good. Okay, ABC, DEF, we're cruising right along. Now, this was completely unnecessary. I did not have to do this here, because if you were paying attention to my pass by value tutorial, you already knew that that was not necessary. So what we've got here is when we originally set this value right here, when we did the constructor, invoked the constructor up here, it said that we're passing it my chars, which is a reference to this object on the heap. Now I changed the values of this object on the heap, but the reference still points to the same object, right? So value still points to the same object. So by changing this right here, we can go ahead and run this without any of that. We didn't need any setter methods. Okay, A, B, C, D, E, F. All right, so if you're following me so far, everything is pretty good there. So let's talk about, what if I had like an override for the substring in here, or a method in here for substring, right? We wouldn't want any classes to be able to override that substring. So how would we prevent that? Well, basically what we'll do is we'll put the final modifier on here, right? And if we come up here and we say extends final, or extends string-like, we won't be able to do that. It's going to give us a compiler error, right? Okay, cannot inherit from final string-like. So that's the first key to starting to make this immutable, right? Is we go ahead and put the final keyword on there. Now final does not affect being able to create an instance of the class, right? It only prevents us from inheriting it. So when we clear the screen and we recompile, we're all good there. Okay, so that's step one of creating a mutable object there. Okay, apply the final modifier to the class to ensure it cannot be inherited. In other words, become a superclass, right? Because we don't want any of our methods to be overridden, because that would be dangerous there. Okay, so now the next step is we want to make our instance variables private and final, right? Okay, so by doing that, well, private, it was already encapsulated. You know, you could only set it once through the constructor there, right? And now by making this final, let's go ahead and see what happens. That means final applied to a reference variable means that the reference variable can never be reassigned to another object, okay? Doesn't mean the value of the object can't be changed. So what we're going to get is we're going to get kind of the same exact thing there. A, B, C, D, E, F, right? You might be going, well, what the heck? Final. Well, final, our value did not change. That reference variable value did not change in there at all. It's still pointing to the same object. This up here, we just changed the values that are inside of that object, but it's still the same original object. We haven't done any new object there. So the next thing that I want to talk about here is got to import this. I'm going to import a Java utility class here, java.utils.arrays, right? And don't worry much about arrays, but basically what we've got is we've got a problem down here is that we really don't want this value here which is this parameter value, we don't want its reference. We actually want a copy of it so that it can have its own unique copy, right? So how can we do that? We can use what's called the array's copy of. All right. And I'm not going to get too much into that here, but I'll show you what will happen there at this point there. But so if we do this dot value equals, and arrays.copy of basically returns a new array that's a copy of this. Actually, I'll just take this completely out here, right? So we've got the value parameter coming in here, right? And it has a length. We can use the value.length, which will basically return back 3, because the dot length portion of her property per se of any array there will return the length of the array. So this will copy the array that this reference is actually pointing to. It'll make a copy of this and return a whole new object so that we can now have value pointing at a whole new object, right? And so by changing it right up here, right, that will change the original array, but by then value is no longer pointing at that original array. Let me go ahead and save this here and I'll show you. Okay, ABC and ABC. Right? Now, instead of this override, just to show you that it's pointing at a you know what, no. Never mind. Okay, so let's see if I can just show you that'll require a lot more coding than I want to do right at the moment. Okay, so anyway, so basically now we have a fully immutable class, and I'm just going to come back to my website here and go over the characteristics that we did to make it immutable. And so I'm just going to reiterate this up here. So an immutable object is an object whose state cannot be modified after it is created, right? And so as you can see, we can't modify it after it's been created up here, even though we changed the value of the original array up here. Now we've got this sucker and it's fully encapsulated, can't be modified, you can't extend it. When final is set like this, right, you cannot change its the value variable, the reference to the object that it points to. So just reiterate all this stuff here. Apply the final modifier to the class to ensure it cannot be inherited. Instance variables or fields should be private and final. Do not create a no argument constructor. Create a constructor or constructors that initializes the private instance variables. This ensures they can only be initialized once. And the final keyword applied to an instance variable, if you try to initialize it again, would go off on an error anyway. So we prevent that from even happening by putting only in the constructors. So remember that Java is passed by value, so any reference variables received as constructor parameters must use a technique called defensive copying. And defensive copying is basically what I went through right here, right? And that's basically creating a whole new array inside of this object here that basically the value, the state here points to. So it no longer has any reference to the original array down here. It has its own array that can't be, that's like encapsulated in there. So do not create any setter methods that change the state values of the object in any way, right? And now that we've marked this final, if we were to try to put our change value back in here, as a matter of fact, it'll give us, it won't even let us compile, because what'll happen here is it sees that we're going to try to set this, and it won't let us. Okay, cannot assign a value to a final variable. Okay, so we can't even do that there, so that's good there. And if you remember back from my final variable tutorial, you have once that variable is initialized once, it can never be changed again. So we're basically declaring it right here, not assigning it any value, which means that the value must be assigned inside of the constructor. And that's in my tutorial there too as well on that. So anyway, let's go ahead and save this. compile it, run it. Oh. Okay, ABC, ABC, right? So we've now got a immutable string-like class, which is basically the same thing as the string does there. So I'm going to just go ahead and close out of this, get this off screen, and leave you with some final thoughts there. So an immutable object is an object whose state cannot be modified after it is created. As your knowledge of Java advances, there are other considerations to keep in mind to ensure that a class is immutable. Now, the rules that I laid out in this tutorial will more than serve as an excellent understanding of what it takes to make a class immutable. That concludes this tutorial. Thanks for watching.